Hello and welcome to the Spotfight developer commentary. First, let's talk about our development workflow. Spotfight is developed in the Unreal Engine 4. Our team mainly consists of 4 people. Our 2 programmers, Max and Michael, Dominic, our lead artist, and Bernd, our sound designer. In addition to that, we also had some external help for the UI, concept art, and backend. Spotfight is developed in an iterative fashion. We mainly work remote and communicate over Discord. For project management purposes, we split our tasks into manageable portions and track them in Jira. Our sprints are mainly 1 to 2 weeks long. Sprints start with a sprint planning, where all team members lay out the plan for the next sprint. Each team member is assigned tasks and works on them during the sprint. At the end of the sprint, we make a build and perform a playtest. The playtest always includes all of our team members, as well as some external playtesters. During the playtest, we gather feedback, which is then discussed within the team. Feedback that we consider to be an improvement to the game is then added to a Jira backlog. This workflow has proven to be very powerful for us, as it allows for a turnaround time of as little as 1 week for feedback. One major mechanic in our game is the vision system. Players can only see enemies within their respective vision areas. Each character has a small vision circle attached to its model, so that you can see your immediate surroundings. In addition to that, there is also a larger circle attached to the mouse cursor. Vision is part of the core gameplay loop in our game. Finding enemies with your mouse cursor is the first step in each player's decision-making process. For the vision system, we had to overcome some difficult technical challenges. Our design required that vision could be selectively blocked by the environment. By default, this is enabled for the circle attached to the character. I will enable this also for the vision shape attached to the mouse cursor for demonstration purposes. This can be done by simply toggling it on and off in the respective component. If I save this and then go back into the game, you should be able to see that now when I point my mouse cursor at the environment, it is blocked by the environment. Behind the scenes, the vision shapes are procedurally generated meshes that update every frame. The meshes are then used to render to the stencil buffer. In the post process, this stencil buffer is then used to shade visible and non-visible areas. In addition to the procedural generation of the vision meshes, the whole vision system has to properly function with multiplayer in mind. To demonstrate this, I will start a game with 3 players and an artificial ping of 60 milliseconds. When I move my mouse cursor, the position and form of the shape not only updates for myself, but also is properly replicated to other players. This required a significant amount of custom tech, including some custom replication logic for the shapes to appear smooth and accurate for all players.
When developing Spotfight, the 2 main things I was in charge of, you could say, is definitely character logic, meaning having a character walk around, shoot, and interact with its environment, as well as the encounter logic and all the logic that comes with that, switching encounters and so on. As you can see, the top-down perspective makes it relatively easy to control the character. There wasn't any big problems to solve there. You could just walk around using the WASD keys, have the character watch or look rather towards the mouse cursor at all times, and then when clicking, have the character shoot. That's pretty much it on that front. One more thing that I developed as well was the weapon system. Now currently in Spotfight, the characters only have one type of weapon, namely these charged weapons that you can charge up and their damage increases, and then when you shoot, it's a more powerful shot. And they're also single shot, as you may have noticed, since the character instantly reloads. Originally this was not planned, and if I go into the weapon real quick, I can show you that there are, hold on, give me a second, there are a lot of there we go, a lot of modifiers that people can modify. So there was originally going to be a sort of a spread where the bullets would fly, so your bullets would not fly perfectly towards your mouse cursor. Depending on how long you aim for, that spread would minimize, I suppose. As you can see here, there are a lot of properties that could be adjusted for weapons, as we originally planned to have a lot of different weapons that people could use as a loadout. The system is still there, and we might incorporate it into future builds, maybe having different weapons depending on which encounters people play. But for now, all of this is basically just a stand-in, you could say, and this charge weapon is the only one that's currently really in use. Now, during our redesign of the game, we decided that Spotfight should overall play like some sort of big tug of war game, metaphorical tug of war game, really, where each tug, you could say, that shifts the momentum of the game into favor of one team or another, consists of one encounter that the teams play versus each other. What we really wanted with these encounters is to have some sort of multidisciplinary match where each encounter can vary wildly from the previous one, and teams would have to adapt and just really, master the game, you could say, master different maps and, of course, the different encounters to consistently win. What you see here is the one encounter that's currently in the game. It's called the delivery encounter, and the goal of the game is this package that I just picked up, to pick up the package and deliver it to the enemy zone, delivery zone, I should say, before the enemy delivers the package. Now, as you can see, the delivery completes, and now I've just scored a point. That's one example of an encounter. And to make these encounters work, what I did was I designed a system that allows for a lot of flexibility. What you could do is we can define these encounters, you can see here for an example, to have pretty much whatever we need to have in the moment. You can define geometry that is loaded at the beginning of the encounter, and you can define gameplay objects for the encounter that is loaded. The reason we split those two up instead of just having everything loaded at once is for even more customization. Sorry. For example, if you have one map that's very well balanced, you might want to use it for multiple encounters. But if you have gameplay objects that are limited to one specific encounter in that map, you can't reuse it. So if I have two encounters on the same map, one of them being a delivery encounter, as we've seen before, and one of them being and let's say a team deathmatch encounter where I don't really need any specific objects, I can still use that specific map and then just for the team deathmatch encounter, just not load any gameplay objects by keeping that field empty. And to go further in customization, you can also choose which character class is loaded. So we can have completely different characters with completely different controls in between encounters. We can specify if encounters should allow a respawn. So let's say you want to play in a more, instead of playing team deathmatch, you want to play, what's it called? Last man standing, for example. You can just take that allow respawn button and untick it, I should say, and you're good to go. Another thing is UI, of course. Since the encounters vary so wildly, you can't really reuse UI elements for most of them. So there's also an option there to just specify which UI gets loaded for each player. The same thing with music and sound. So there's just a lot of customization that's possible with these encounters. And as the game develops, there's going to be a lot more different encounters that will make use of this system to be really distinct from one another.
The art style of our game is inspired by black and white comics. Specifically comic books by Frank Miller, like Sin City for example. Here you can see an early concept I did for how our game might look like. The goal was to create a high contrast image with some color accents. Things like blood, items or objects can have color, but the map itself is black and white. A core feature for our game is the spotlight, which is the main thing that creates contrast. Another detail we wanted for our game are these comic sound effects descriptions. We call them Vsfx for visual sound effects. So, how do we achieve this look in our case? First off, the spotlight. In the game, every object has two viewing modes, a visible and a non-visible view. What part of the game is visible and what part is not visible is determined by a custom stencil value. Now, in a post-process material, we decide what color an object should have based on its base color for its visible part, and for its non-visible part, we use the metallic roughness and specular values as RGB values respectively. This means that in each material we can set the values so. Here's an example of the wall material. If it's visible, it should be rendered white, otherwise it should be rendered black. By doing this for every material, we get this spotlight look. For our visual sound effects, we use widget blueprints. The reason for that is that if a widget is rendered in screen space, it does not interfere with the post-process material. So we can guarantee that it will always be rendered on top. How and when these Vsfx appear is controlled by code in the background. Something else that was quite tricky is the in-game UI. Because of the way the game works, most of the attention of a player is naturally focused on the visible part of the screen. So in essence, either on the spotlight or the character. This creates the problem that as a player, you don't often look to the sides to check your status or your health. Our solution was to implement as much information in the character and the spotlight itself as possible. This is why most of the necessary information for the game can be seen in some form near the character. On the top left of the character, you can see the melee action cooldown. You can see your health bar around your character in a circle. Of course, you can also see your team color. Small arrows around you indicate where your teammates are. Your aim reticle shows your charge status with an animation, and at 100% charge, small red triangles are added to it. And when your dash goes off cooldown, a small Vsfx element pops up.